Hi everyone, it's Coach Fred here, and this video is going to be going over absolute value equations and inequalities. Now, depending on your Algebra 1 class and how long it's been, you might need additional support on this. I have several videos on my Coach Fred's Algebra 1 and Algebra 2 playlists on YouTube, as well as you could use Khan Academy to learn more. So I'm going to go through this very quickly. Remember, it's more of a review. Okay, so first we really need to understand that absolute values definition, like what it means is the distance a number is from zero on a number line. So if I give you, and the symbols are these two bars, so if I give you something like this is saying that the distance from zero is 2 units. So the absolute value of -2 would be 2. Now, it becomes a little trickier when we have equations that involve an x. All right, so let's look at solving absolute value equations involving a variable. All right, so if I gave you like the absolute value of x minus 2 equals 4, geometrically, a picture of what's happening here is basically saying that the distance from the number 2, not -2, and we'll talk about that later, the distance from 2 to some x is 4 units. That's what this means. The distance from 2 to some x is 4 units. So let's think about it. X 4 units could be here, but it could also be here. This distance is 4, and this distance is 4. So that means that this geometrically would have to be, x would have to be 6, and geometrically over here it would have to be, let's see what, -2? All right, how do we solve it algebraically? Well, algebraically, the first thing you have to do is you have to isolate your bars. So what that means is if I gave you something like this, you can't distribute that 2 that's on the outside. It's being multiplied to the absolute value. So you need to isolate the bars by first dividing by 2. And, if I gave you something like this, you'd have to first subtract 3. So treat those bars kind of like an x, what you do for x in the beginning. So isolate the bars first. So here we have that. Once the bars are isolated, algebraically, the rule is, or the reasoning here would be you write 2 separate equations. You can take it out of the bars, set the first one equal to 4, just like it's written, and then set the second one equal to -4, indicating that you're going in the negative direction. So then you can solve them. So we're going to add 2 on both sides, and we're going to get x equals 6 and x equals -2. Now, geometrically, the answer would be 2 dots at those locations. So if they asked you to graph that, you'd have a point -2, and you'd have a dot on it, and you'd have a point 6, and that's because it equals those numbers. Okay, but what happens when we work with inequalities? Okay, so let's look at inequalities with absolute value. Okay, so we're first going to look at less than, or obviously less than or equal to. Okay, all right, so let's use that exact same equation. What if I said the absolute value of x minus 2 is a less than 4? Now, I could also make that less than or equal to, so just remember that. First of all, this means less than inequalities involve something called overlap. Okay, so if you think of a Venn diagram for a second, overlap is everything that is in both circles. All right, when we think about this, we're saying that geometrically, we're saying that the distance from 2 is less than 4 units to x. Okay, so here's x, and here's x again. Remember, we don't know which direction. But less than 4 units would be everything that would be less than 4 units, not actually equal to 4 units. So look at that graph. Your answers are all the values between the 2 values. So that's a geometric representation. To solve it algebraically, take it out of the bars. So first isolate those bars. That's the most important thing that you do first. And then take it out of the bars, and you can actually put your inequality between 4 and -4. Think of the answer here between the two answers. So you can put your equation or expression in between 4 and -4. Then solve it simultaneously by adding 2 to both sides. And you can see that this graph is a compound inequality with my answers between 6 and -2 and 6. Voila. Okay, now remember, less than inequalities involve overlap and your values are usually going to be between two endpoints. Now it gets a little trickier when we're talking about greater than. Okay, greater than, or obviously greater than or equal to. All right, so when we look at these geometrically, we use that exact same inequality. I'll use equal to this time. It's saying that I want all the values that are greater than 4 units from 2. So if I'm here at 2 again, and we know that our values that are 4 away are -2 and 6, well, greater than that and equal to would be everything like this. Now, greater than, I also like to write it with a or at the end, greater than, because we call these or inequalities. We can write them as a compound or inequality because it's one or the other. Any number greater than 6 or any number less than 2 will satisfy this inequality. It will make the inequality a true statement. So algebraically, how do we do this? You can use compound inequalities just like I did here. I wrote a compound inequality to solve it. You can do the exact same thing with greater than or equal to. Okay, so first again, we isolate those bars, but here's our inequality. Let's pretend everything's been isolated. Now here with ors, you can write 2 separate inequalities, 2 separate that involve or. So first, the first one's exactly as we've written it. Oh, sorry, greater than 4. Or, and or is actually part of it, the absolute value of x minus 2 is less than or equal to -4. Notice you have to change it. You have to change the direction because remember, we're going to the left towards that negative. Oh, and I didn't get rid of the bars, but you can when you write the inequality. Let me fix that. And then you solve. So x is greater than or equal to 6, or x is less than or equal to -2. And then if I look at my graph, here's -2, here's 6, and I want everything greater than that and less than that. And you can see that ors oftentimes, not always, oftentimes point out. Now, it is important to know that there are situations where you can get an all real numbers or a no solution. So if I have a less than or equal to, and it's supposed to be everything in between, but my inequality doesn't overlap, it would be no solution. Just like if I had an or inequality and like my answer worked out to be something like this, then that would be all real numbers because every single number on the number line could satisfy the inequality. And here's the basics, guys. If it's me, it's absolute value, I'm always going to test my answers and make sure that the value I get or a value within the solution set makes the inequality a true statement. And when I think absolute value, I usually always like to think of 2 answers. Okay, so hopefully that was helpful, but remember it was a very quick and basic review. If you didn't feel as comfortable with this material in Algebra 1, or this was like, oh my God, I totally forgot, great idea to go back to my YouTube channel for an absolute value equations and inequalities video, or again, use Khan Academy. All right, have a great day.